in today's electronics, things are getting smaller and smaller. Capacitors, resistors, inductors, they are getting smaller and smaller. Very difficult to measure, and they become so densely populated that it's impossible to sort of do the easy measurements or to find the actual faulty capacitor or inductor or resistor. Nonetheless, there is instruments already available on the market, LCR meters and things like that. Now, can you measure them on the board once in the circuit? The answer is yes and no, with a high degree of accuracy. Now, once the component, say for argument's sake, capacitor, bipolar, non-bipolar, should I say non-polar, polarized aluminum, whatever, very easy to measure with a certain degree of accuracy. This is what have I picked up here. That's 100 microfarad 25 volt. Of course, there is tolerances which the manufacturers allow you. So this one will read, let's see what it says. Okay, it's about 91.9 microfarad, and if you look at the D on top, that's a decrement factor, that's a 0.71, which is indicates to me that this capacitor is a fairly good condition, because the decrement factor from my own notes or whatever should be anyway not below 0.25. Because every manufacturer gives you the summary notes on the capacitors and so on. What is your minimum, maximum sort of specs on the particular series of capacitors and things like that, whether it's a polar, non-polar, bipolar, and so on. Now, let's look at it over here on the non-polar. Again, this is, what is it there? The 220 nanofarad, 400 volt. Let's see, what does it say? So it's quite easy to measure them once they, let me just put it to a higher frequency, to 1 kilohertz. Okay, 220 nanofarad, and if you look at it there on top, the D, 0.004, and that's this one here on top, okay? And on the new capacitor, 0.00 whatever, starts from 0.02, 0.4, it tells me the isolation and everything should be in order, and this capacitor is in very good condition. However, once you fit the component, whether it's a conventional through hole or whether it's a surface mount component like this, if you look at it, surface mount, different or electrolytic capacitors or inductors or resistors, they can get actually influenced by the other circuitry. And also, if you do use a fluke meters or any meter for that matter to measure the resistance or capacitance in circuit, they do supply quite a high voltage. So you can stand a chance of damaging today's electronics. Some specialized sort of chips which go down and operate, or semiconductors that operate like 0.1 volt, 0.8 volt, you cannot exceed. So what is the solution? Of course, you don't have to know your electronics, and it shouldn't be a problem. With an instrument like this that I use, I've got different type of probes that I can attach over here for a surface mount capacitors or components with a gap of 0.5 millimeter, 1/4 millimeter, and things like that. That we calibrate the instrument, and then, but in this sort of demo, I'm going to use tweezers. Okay, so now if you look at it, let's start with the electrolytic one. If you look at it over here, that's 3.3 microfarad, 400 volt. Okay, usually electrolytic of that value, every manufacturer gives you, as I said, prescribed voltages and prescribe frequencies that capacitors, doesn't matter polar, non-polar or bipolar, they should be measured at. And unfortunately, this instrument is limited to whatever, but it's much faster than the other sort of ways that I actually use. Let me just show you. That I use, let me just show you over here. That I use with what you call it, or with the instruments, if you look at it over there, part 1, where I can really sort of with 100% accuracy determine whether the capacitor is done. I can even measure the leakage current according to the charts that manufacturer supplies. Part 1, there's different charts over there, which actually makes it very easy for me to, with a high precision. But for a quick, imagine it's a big board, a big PC board, okay? And it's got like maybe 50 or maybe 60, 70 capacitors. The easiest way, and what we would do, we would use, this commercially available, there is like a tweezer instrument, part 1, which are good. They got a place sort of in a toolbox, but I do not really recommend them because it's basically, to me, it's a waste of time. I prefer benchtop instrument. The reason why, because it gives me a bit better accuracy and more versatility, because I can measure at several different more frequencies and different voltages. So right now, let me measure this 3.3 microfarad. Okay, and okay, let me change it to 120. Okay, again, okay, we're gonna measure it. It shows me 3 microfarad decrement factor. The decrement factor, that's actually angle measured between the ESR and the actual XC, inductive reactance. I don't want to go too technical or whatever, but that's what basically it tells me. Okay, it's inverted of the actual impedance. Let's put it in a simplistic manner. Now, I prefer sort of reading it. I can measure, of course, if you look at it over there, I can measure the Q factor, and I can apply different sort of readings and formulas and whatever, the charts, and I can see instantaneous if this capacitor is it within its operating. But I prefer using the decrement factor because that is a bit more faster and more accurate than the actual Q factor. So this capacitor does pass the test, etc. and so on. And now let's try this one here. That's a 5.6 nanofarad, this particular cap. Let's see what does it measure, okay, with my tweezers. Okay, all right, it shows me 5.56 nanofarad, decrement factor, 0.002. Sorry, I'm not making a connection. 0.002, which means the capacitor, although it's in circuit, I am able to measure these particular caps. Okay, let me try the surface mount, which is 3 millimeter.